Hi, and welcome to Person Platform. Person Platform is a new podcast for platform engineers and begins with a short series of episodes hosting engineers who build tooling for secure workload and service access. In each episode, we'll be digging into what was the motivation behind building the system, a bit of the origin story, lessons learned, and have lots of fun. I'm Ori Shoshan, by day the co-founder / CTO of Authorize, where we make declarative workload IAM finally easy. Joining me this time is Jack Kleeman, who's now a staff engineer at Restate, and they make durable execution just work. Think AWS Lambda and that sort of thing. Before that, Jack worked at Apple as a Senior SRE and at Monzo as a Senior Platform Engineer. At Monzo, Jack led projects on secret distribution, certificate management, network isolation, and in particular, he led the project on achieving zero trust on Kubernetes using network policies, which has an awesome blog post that I recommend reading and we'll be digging into today. Let's begin.
Yeah, awesome. Thanks for having me on.
Yeah, it's great to have you. So we start with a few warm-up questions to get us in the mood. So what are two must-have tools to deploy on a Kubernetes cluster and one common tool you prefer not to use?
Yeah, so being from Apple, the tool that I think everyone should use now that it's open source is this thing called Pickle, PKL, which is a new configuration language, a little bit similar to Q or JSONet, but much better. I'm hopefully going to be talking about it a little bit at KubeCon this year. It's really, really brilliant, and we should all be configuring our clusters this way. Less YAML, more Pickle. That was the first one.
Because of all the late binding stuff, right? You told me
that. Yeah, so you can have files that like have the structure and validation of a resource, like a network policy, but don't fill in all the fields yet, and can sort of slowly, incrementally with overlays get more fields until at the end, like right before being output, they get checked to have all of the type safety and stuff. And this is just this is the way that we think about managing real life configuration, and it actually works in the language.
Yeah. Like Helm forces you to, Helm with its values YAML forces you to find creative solutions. And now there are better tools for that nowadays, like a Helm file, but you used to have to do acrobatics to deal with the fact that values YAML cannot bind to variables. But sometimes you need that.
Absolutely. Yeah. And I guess in skipping to the sort of what wouldn't I use tool, I would say, I mean, at face value, Helm, but I think that maybe Helm plus Pickle, there is something in this. So this is maybe something I'm going to be working on the next few months and maybe talking about a KubeCon is combining these two and maybe making something that is better than the sum of their parts. Because Helm for like repo management, like artifact management, the fact that there's just like you can just pull in like Docker style, just pull in something. This is really amazing. But the values.yaml and the Go templating is just melts my brain. So maybe something we can do in this area.
Yep, it's always terribly complicated, and when you start, having charts that depend on other charts and want to use their values, it gets
painful. It's really, really painful. Yeah, but it's unavoidable. I mean, at Restate, we also did like Helm charts to help people deploy, and that's probably one of our most used things. And it's like, it's just a pain that we all have to bear. But I have hope that this can be improved. And yet, to speak positively, the second tool that I would say must have is external DNS. So this is like a really simple controller. I think it's managed like as part of the Kubernetes OSS, but it has plugins for all of the cloud providers, and it creates DNS entries for you. So you can just like label service objects, ingress objects, and it will just like magically, there will be DNS names that point to them. And this is just so helpful, not just for external usage, but also like for internal things. And I used to have to spend a lot of time going into the Route 53 UI and doing this kind of stuff, and now I don't have to do that at all.
Yeah,
so really recommend it. As I think we're going to talk about a little bit today, I'm a big fan of declarative configuration, and this just makes things so much better.
Yep. I was fortunate enough to start with Kubernetes at a point where external DNS was a thing that was popular already. Yeah. Before that, I used Mesos and, Marathon and all that. But I managed to skip the phase where it's not obvious to use external DNS and everything was declarative and nice. I can't imagine going back to configuring DNS. It's just so fragile. So many incidents.
Yeah. I mean, I still have to do it a bit with like Cloudflare records for our main domain name and stuff. And there's like junk in there from ages ago. There's like certificate validation things. It's just so annoying. So yeah, need to clean that up.
It hurts every DevOps engineer in the core being to see stale entries.
And kind of think, I kind of know I can remove these, but probably no one else does. And therefore, if I don't remove them, they'll just never be removed because it's too scary.
Yeah.
I remember Apple just had like legions of these kinds of records that they were never going to be removed. Like couldn't be done.
Yep, you need to be a little bit brave to remove them.
Definitely.
So awesome. I gave a little bit of intro about you, but now it's your turn to say it in your words. So who do you work for? What do you do?
So I work for a company called Restate. It's a reasonably small startup founded in Germany, but I work remotely from the UK. And we work on durable execution, which is kind of a fancy way of saying we want applications to write down more about what they're doing so that when they fail, they can resume from where they failed instead of doing like naive retry strategies and things like that. I spent the early days of my career, as I think we'll talk about, working on service meshes, like essentially making it easier for microservices to communicate. And those generally have retry strategies that lead to a lot of like failure amplification, like loads of load from failure. And I kind of started to think maybe computers are fast enough now that they could do this a little bit more intelligently, write things down to like a database, to a disk, and be more stateful. And Restate and durable execution are basically a way of doing that. So we're trying to make that easier, faster, more efficient, better developer experience, just all around more ubiquitous. So yeah.
I suddenly had a thought when you were explaining. I've heard you tell me what Restate is before, and I've gone to Restate's website, read some of your blogs, some of it that you've written, but I just realized that the concept behind durable execution is, if you take it down to the low level, it exists in CPUs today, right? When a CPU gets an interrupt and it saves the context to the stack and then jumps elsewhere and then restores it, that's kind of like that.
It's actually, or even at a slightly higher level, the way that Go does like coroutine stuff. It basically saves a stack and resumes it when there's an await point. And this is actually like incredibly similar to our approach. The only difference being that we don't try and serialize the stack because this is really fragile. And like, if let's say you change the binary even slightly and then try to resume, it will just kind of not work. It'll probably segfault. So instead, we focus on like writing down the side effects, like the important IO, the expensive operations, and then everything else just gets kind of run again, but without the side effects occurring. So that's the kind of hack, I guess. But in practice, this works really well. And yeah, I mean, distributed coroutines is definitely one way to look at it.
That's very cool. Seriously. So yeah, that's really awesome. Like, I've spoken to you about Restate before, but I feel like it's the first time I've thought about it not as a set of features or something I've even experienced myself, where I've had the misfortune of implementing Lambda continuations on AWS to walk around the time limit on running Lambdas and sort of trying to serialize the state and resume, and like millions of bugs, millions. I'm not exaggerating at all in the number.
The classic. And I think there's just like there's a primitive that we're all looking for here. In the same way that Kubernetes was like a primitive for orchestrating compute, I want that to be a primitive for kind of keeping track of intermediate state and doing this like fast and efficiently enough that this is not expensive, this is not complicated, but also doesn't require a lot of thought, doesn't require like a lot of use case design and this kinds of stuff. So this is the mission for me. And yeah, there's a lot of interesting engineering as well behind this, which is why I love it.
Yeah. So it's the first time I've really grokked it on almost. I understand it at a technical level, but now I feel like I understood the scientific ethos behind it. Like, what is it a parallel to elsewhere?
Yeah, absolutely.
Which is cool. I had a cool moment.
Great.
So yeah, tell us a bit about like what you do on the day-to-day.
So I mean, I was hired as sort of the first cloud engineer. Most of my colleagues come from more of like a core database development and design background. But my career is mostly, almost entirely Kubernetes, orchestrating services. And I guess we knew early on that Restate at some point is going to have some kind of cloud service. So I was hired partly to help with that, partly also brought some Go expertise. So I work on like our Go SDKs and things like that. But yeah, this year I spent most of the time building out like a really early cloud platform. So in practice, that looks like sort of running clusters for users in Kubernetes, being able to create them on demand very rapidly, keeping them secure. They need to be really isolated from each other, have like resource constraints, things like that. So I mean, this really like in many ways I could be deploying anything. Like this is just like a very core stateful system managed service project. But yeah, around the fringes, I get to also work on the core Restate runtime. I learned Rust to do that, and that's just been really awesome as well.
Very hardcore. I always got a little bit daunted by all the things that look like comments in Rust but aren't actually comments and are syntactically meaningful.
Yeah, I mean, when I was a real Go fanboy, like this is the kind of stuff I would have criticized. I say, oh, it's not readable, and oh, it's overcomplicated, and it allows engineers can abuse these things and use them where they shouldn't, and all of those things are true. But now that I've started doing all of that stuff, I can't go back. So I've been writing a lot of Go the last few months, and I've been finding it really, really hard. I just feel like I've lost so much safety. I feel scared.
You have to think about it now.
I think about it. Rust, when I was learning, it was just horrible. But I mean, not horrible, but a really, really, really hard learning curve. And then now that I know it, it feels really comfortable, and everything else feels terrifying.
Because you kind of have guardrails right now, right? The compiler is keeping you safe.
Yeah, I mean, I used to think that Go was quite a high-level language, but having gone back to it, I put it closer in the camp of C, where it's like there's, I can just do like nil exceptions wherever I like. I can do data races. These are things that I just became used to not happening in Rust. Like I can't do those things at all. And yeah, I find it quite scary. There is maybe a little bit of like you can do what you want, I guess, which is good. And I guess the other thing about Go is that it doesn't make you obsess over performance, whereas Rust has really made me. Even when I'm writing like a Kubernetes controller in Rust, which is like objectively, this is asynchronous, this runs in a loop, it's fine. I'm still thinking like, oh, that's an extra allocation. And this is just a mental way to write software. It just makes no sense.
Yeah.
You would never think that way. And that's definitely a problem that like, if you're writing higher level application code that isn't performance sensitive, it will flip your mind into this bad state.
Right. You want to think about performance when you need to think about performance. Like, when you have an issue, or if you know it, like low latency is really critical, like you're trying to achieve really high throughput or something like that.
But I think more than anything, engineers just find it fun to obsess over these things. It also allows them to waste a lot of time doing something that's fun instead of like doing the thing that they're supposed to be doing. It's like procrastination. And it also allows you to kind of be a bit annoying to your colleagues and be like, oh, you could do this a little bit more efficiently. And like, all of these things are just like toxic traits, which the language kind of encourages, but it's kind of fun. But you have to reel that in. And I think Go does an amazing job of just being like, this is just, we don't do that. Like we don't think about these things. We don't worry about them.
We don't do that here.
Exactly. I think it's just a real cultural thing between the two languages, and I really respect that about Go. But now that my mindset has shifted a bit, it's difficult, really, really difficult to get back. Just silly.
Definitely, I can see all the fun in figuring out low-level stuff and how, like, can I do this a little bit better? It's right there. Like, once you have to make a choice about, like, how do I allocate this? How do I pass ownership? You become aware of all the options, and then, like, you don't want to intentionally make a subpar choice, right? That would suck. With Go, you don't make a choice a lot of times.
There are ways to solve the same problem. I mean, especially when it comes to like async things, and when you're dealing with references, and like it starts to become a lot of different approaches, and also they're changing a fair bit. Like the language is actively still changing quite significantly from month to month. So it really makes you analyze every decision that you're making. And most of the time, you're just making some web requests and dealing with responses, and maybe it's going to get one request per second, and it's just fine. It's just like,
one request per second. That sounds like really high load.
Yeah, it's so silly, but it will just make you think, oh, can I do this without copying like any state? at all, like per request, like just zero copy. I mean, obviously you can do that in Rust. You can't do it in Go, but do you need to do that? No, of course you don't. It's just ridiculous, but it's fun.
Yeah, I'm familiar with that obsession. Back when I was writing anti-malware in C++, I would be obsessed with, can I not copy this buffer? I switched from protobuf to flat buffers and zero copy everything. And C++ is like a lot of magic incantations because the compiler, there are rules about what's guaranteed, but they change and none of them are obvious.
Yeah.
It's like knowing the Bible. You got to know like what's the right prayer for this situation.
And I think I try to avoid that, but there's still a little bit of that where you can see that like tastes change and people want like, they think different things are recommended now. And yeah, I mean, it can get a little bit silly at times, but it is fun.
Yep. That's important too. Keeps people going.
For sure.
So how do you get into platform engineering or like DevOps or SRE or infra?
Actually through security, basically. So my first sort of meaningful software engineering job was at Monzo in the UK, and I joined the security team. And yeah, I mean, when you're already on like a Kubernetes first microservices platform, I guess you can go in a few different directions. You can go for like application security. So Monzo is a bank, so that generally means controls around like people's accounts, and also thinking about like customer support and making sure that their interactions with accounts are safe and that they're doing the right things. But I was always drawn more towards platform security, which is like, we have all of these applications running. First of all, what can they do? Can they talk to each other? Can they do things that they're not supposed to do? Can they be misused? And then also the machines that they run on, getting onto them. How do they control that? How do we audit it? And it's funny, really, because those kinds of problems are kind of completely unrelated to what the applications actually do, which is kind of similar to what I was just saying about what I do at Restate. Like, I kind of find these black box platform problems quite interesting. So yeah, the more I cared about security, I guess the more it became obvious that I needed to be a platform engineer. And I found it really difficult to do only one of those things, I guess. Like, you can maybe be a platform engineer, but not care at all about security, but that leads to pretty bad outcomes, especially if you work in a bank. But I don't really know how you can be a security engineer, at least with our platform, without being to some extent a platform engineer, because it's just such a different way of thinking about infrastructure. Typically banking regulations point towards lots, like very small number of big services that have firewalls and, who are completely air gapped from each other and like, do loads of stuff and just do function calls. And we instead had this like big networked complex set of services with very tightly defined responsibilities. And this is just really difficult and novel security problem. So yeah, I guess I got into platform engineering by trying to solve that problem. And by the end of that process, I wasn't really a security engineer anymore, not in the traditional sense. And after that, I never did another security job, as much as I still think that's something I'm really passionate about. I found it really difficult to find these roles where you do both of those two hats, because usually it's like, oh, you're a security person, you have policies, you do audits, maybe you do some red teaming, but you don't tend to like make new Kubernetes applications, like complex controllers and things like that. So yeah, now I'm a platform engineer or an SRE, I guess.
Yeah, I can imagine that as a security engineer, the role varies a lot depending on the company and the culture of the company, and only very advanced, new tech startup style company like Monzo, you'd end up doing both.
Yeah,
it's almost table stakes. Like, how do you set security policies and work with engineers on security if you can't even speak the language, right? Kubernetes reinvented all the words, basically.
Yeah.
So you can't even understand what they're talking about anymore, because it's not processes, it's containers, they're running in pods. What's the difference? How does that relate to my life?
Absolutely. The impetus for us was going through PCI, which, pretty much every financial services company has to go through at some point. And there are so many concepts in there that are geared towards, 2000s and 1990s technology. And you just have to like reinvent all of this stuff in cloud native world, which is, a really fun problem for an engineer at the start of their career. Absolutely. But it's also a ton of work. And it was kind of funny to me at the time that so many different companies were having to come up with their own approaches to like controlling networking, controlling access management, all these things that are in the PCI spec. that maybe they once had like an appliance that does all of that for them, but now they have to implement it all themselves, which is a lot of.
I feel like that's generally the software world. We're just in a cycle of endlessly re-implementing the same concepts, but at a different abstraction layer.
Yeah. Maybe it's good. I don't know. I kind of hate these like
Progress.
we're like we only had it all in the 90s. We had it with OCaml, like nothing is new. And we hear that sometimes with Restate as well. They're like, oh, we had Akka or whatever. But yeah, I think that we have gained a lot. I mean, microservices in particular have made problems much harder in like many of these kinds of problems, especially on the platform side. But I think that they've made collaboration amongst application teams much easier. And that's maybe a harder problem. Like platform problems can be solved, platform problems can be abstracted away, but like the problem of building product and having lots of product teams individually deploying, not having to do monthly release cycles, these are like real meaningful problems that affect like businesses' ability to succeed, I guess. And I guess that's why I like microservices. And I think that the platform team should just make it work for their end users. Like our responsibility is that you can have the best possible development experience on the product side. And if that means the most insanely complicated distributed system under that, then fine, we'll have to make that work.
It's kind of like the Toyota approach, where that Toyota cars, they don't have the region paddles or the region config, like you can't make it harder or weaker. And the idea is that in a Toyota car, if you press gas or you brake, it should just work, right? They should figure out that the platform should figure out how much to region depending on what you're trying to do. You shouldn't bother the driver with making those choices. It's just your responsibility.
Yeah, I think that's absolutely our job. And I think that to take away some of these things that we've developed is to often to move complexities onto the product engineer, say, oh, well, actually, maybe you should have to maintain your own network rules or something like that. Or maybe you should have to, I don't know, deploy by SSHing and FTPing the code or something, or do your own builds. And like all of these things are expecting more from product engineers, which of course they're perfectly capable of it, but they're going to be less productive and they're going to get less done, and then the business is going to die or whatever. I'm being silly, but like I think that's the point. That's the point. We're meant to be abstracting away. People like me, we don't care at all what the product is necessarily. We just focus on the platform, and that allows us to specialize. And then people on the product side, maybe they don't even know they're running on Kubernetes. I mean, I think at Monzo, by the end, that was basically true. Like you have absolutely no interactions with Kubernetes whatsoever, but you have somewhere deep underground, there is some platform that just seems to work from your perspective. This is like the dream for me. So, yeah.
Yeah, it just means like technology can go two ways. It can make your life easier, and it can make your life harder. And I think that the difference is like, is the abstraction right for the use case? If it is, like in Toyota's case, then it makes your life easier. But like with a Tesla, you also have the same setting of region, but it's always too hard, right? Unless you're actually trying to stop. Anyway, so what did you do before Cloud Native and Kubernetes? So before that role at Monzo?
Before Monzo, I was at university studying. So yeah, Monzo was a very early adopter of Kubernetes. I think we were running 8 for quite a while. So by the time that I joined, they'd actually already been using it for about a year or more, maybe. And I was lucky to basically spend my entire professional software engineering life using it in production, which is, really awesome. And then sort of 2 or 3 years later, it absolutely exploded. And I found myself very fortunate that I'd gained all of these skills on this platform that now was becoming the standard. And now it just feels like the fact that there was ever a container wars is kind of amusing to me in hindsight. It's like I literally know one else doing anything else. And every now and then there's like a Hacker News blog post about how I'm still doing code over FTP or whatever, and this is why it's really good. And yeah, that's fine. But pretty much everyone is using Kubernetes now, and they're using it even in the cases where they have 1 or 2 applications. And that used to be like the joke, like why do people do that? But I still think that that's easier than almost any other way of running Kubernetes, running containers. And generally, it's containers that I want to run. I have tried I've tried everything.
Like that's gotten easier, right? Because to use Kubernetes before used to mean you need to know what kubeadm is, and you need to know how to deploy it, and you need to spin up nodes. Like even EKS, until not that long ago, you had to spin up your own nodes. You'd get like a control plane. That's it.
Really. I mean, yeah, we did nothing at Monzo. We were running our own Kubernetes in the same Apple, and yeah, it was really really hard. And I guess I was forged in that fire, and I learned a lot. But the idea that people would be doing something like that just to run a few pods seemed mad. But now, Restate, I have a much less multi-tenant stack. Mostly I just want to run like Restate pods. An arbitrary number of them. But for EKS, it's just amazing for this. And even if I was running 3 instead of hundreds, that would still be worth using EKS because it's auto-scaling, and I can put the control plane all on Fargate, like any kind of controllers or anything like that. I can make sure it doesn't run on the nodes, and it's just like such an amazing user experience. Once I figured out the configuration management side of things, which I think is still hard, it just doesn't fail at all, ever. So this just means for me, like, this is here to stay. This has just become the open standard. Like I was saying earlier about primitives, like we just have a primitive now for running containers, and I'm glad it's the one that I spent my whole career doing. I have to say, but yeah, I do think it is a great tool.
Yeah, for sure. It's gotten a lot easier, and like now, if you use Kubernetes for 1 or 2 pods, you're not missing out on much. And in fact, the tools to get external DNS deployed, cert manager, all that, things that you used to have to figure out, like which provider do I use or whatever, you just help install it.
Absolutely. And just lock in than using, like, obviously you can use like AWS App Runner or Beanstalk or something like that. And I think for certain small applications or like web applications, these things make a lot of sense. But then you are very much like locked into that, and sometimes the pricing is pretty wacky. And I really like that with things like external DNS, you can have this declarative config that is not even aware of the cloud in which it runs, and you just kind of have like a list of primitives you need from the cloud. Okay, I needed to have managed Kubernetes, I needed to have some kind of DNS, I needed to have machines, but basically things that everyone has, and you have a lot of ability to move between clouds, or at least to know that you could, if you had to, if the pricing went crazy, if Google Cloud gets shut down, whatever it is, all things that could happen. So yeah, I think for me, it's a ubiquitous tool that I think should be used as much as possible, basically.
Yep. It's just gotten really good. At Otherwise, we even moved from AWS to Google Cloud, and honestly, it was one day's work because 99% was just, redeploying, and the one day was spent doing zero downtime. You gotta allocate a load balancer on this side.
Yeah.
You gotta do a bit of.
For sure. If you can't just do a maintenance window at 4 a.m. or something, it's definitely a hard problem.
It wasn't zero downtime, right? It was just very little downtime to the point where you might not notice.
For sure. Yeah. These things are always problems, but
it wasn't very hard, even though we were like switching clouds, which makes it a bit harder. Like if you're just switching accounts in Google Cloud, you could maybe even get the same IP address or something, and that makes it a bit easier.
Wow. Yeah, good luck doing that on Amazon.
I think it's probably possible, but I recall having trouble, pre-allocating the address, and then because you gotta have the address assigned to your account, and then just grab it in the ELB, ALB, whatever. And then it takes a few seconds. So we're over to our main topic. So you led the effort to achieve zero trust and improve security for workloads running Kubernetes using network policies primarily and initially. So before we dive into that, can you tell us what zero trust is? Zero trust is a very broad term. Sometimes people mean they don't trust the developers. Sometimes they mean they don't trust the network. Sometimes they mean users have to authenticate. And then also give us a little primer on what are network policies in that context.
Sure. So it's interesting that you mentioned about not trusting engineers, because this was obviously a big debate for us. We in the end define zero trust to essentially be that we don't trust anything other than the code in the repo that's been through approval. So the idea being that the moment that it goes from the repo and it goes through a build system that could be infected, of course, I mean, that's a classic attack. It then goes into a container that, I don't know, could have some process injected. It goes onto a machine that could already have an attacker running on it. These are when things become insecure. So obviously any of those things is already really bad, and any malicious actor in your infrastructure is a concerning thing, but we care about the blast radius fundamentally. We want to limit that to be as little as possible. Services that can't do dangerous things like move money in the case of a bank, they shouldn't be able to do those things. So that's kind of what Zero Trust meant for us, is that things have the minimum possible allowed set of actions, and they could only do those things. I mean, when you read stories about how people get hacked, other than just your classic phishing, it's often like those kind of weird, unusual singleton services that sort of do something minor that no one really thought about, and they didn't update it, and then it sort of has, like, for some reason it has port 22 open, and it's those kinds of weird things. They don't usually need to be able to, for example, move money on your core banking system. So it's really important that it can't. It sounds obvious, but in a naive Kubernetes installation, everything running in Kubernetes is going to be able to talk to everything. And that's true even on AWS, where AWS obviously has strict security groups for any other kind of things. If you're running Kubernetes pods, typically they can all talk to each other. So this requires a lot of thought. And the solution, as you mentioned, in Kubernetes is network policies, which are not by themselves implemented by Kubernetes. They are literally just a resource that allows you to describe kind of pairs of services that can talk to each other and the ports on which they can talk to each other. So it's a very blunt tool, and it's implemented by some cloud providers in their like default networking. And then there are also providers that you can bring in, like Resilium, Calico, that also have their own implementations. And the basic tool that they have is blocking packets. They typically will just block SYN packets for TCP, prevent new connections between two IP addresses that it doesn't think should be allowed to talk to each other. And this is, like I said, very blunt, but if you can manage them well, then it becomes kind of like IP tables rules, which fundamentally issue any behavior you want in your infrastructure. You can have incredibly complicated permission setup and authentication and complex relationships between services, and in the end, it just comes down to really simple rules between services.
So basically, it's like the Kubernetes version of the firewall rules of old.
Exactly, yeah.
Except in a YAML, because we like it better.
And so IP addresses, you can refer to labels on pods, which is a lifesaver. So, everything networking level can be very ephemeral and can change, but you need to label your pods in such a way that it determines, that they can call something or they can't be called by something. And this inherently means you need to trust the labels. So we're not zero trusting, we're trusting some aspect of the configuration of the system. So we want that to be defined somewhere that we trust, i.e. like in a repo that has approval. And then we need to be quite careful about what can update those things.
So having access to think about what your trust model is, like what does your SDLC process, the software development lifecycle, look like? And where are your sensitive points? Like, I think actually it was somebody else on the podcast who told me this. I think it was Andrew Fong, that you may think you have zero trust, but like, have you thought about what permissions your HR team effectively has? Because they can add somebody to a group and then they have access to something they couldn't before. Absolutely. So I guess it depends all on what's the threat, right? But what's the threat you're trying to solve? But you have to think about those things.
Absolutely. And in the case of Kubernetes, anything other than extremely naive Kubernetes API access can be extremely dangerous. Something as simple as read secrets is very, very bad. Read config maps can be pretty bad. Certainly in this case, create network policies is like disaster. Obviously, run pods is disaster. So you have to be very, very careful about like access to the Kubernetes API. That needs to sort of become God. Like, this is the thing that controls everything, and we have to trust like what Kubernetes says is true is true. So ideally, we want that to reflect the repo, which should also reflect approved things from engineers that have access to the repo. And like, that's kind of our chain. Once we've controlled that chain, then we can start to trust what Kubernetes says. And from that point, we can then build lots of layers of like complex trust between services. We can also build identity. So using a Kubernetes, information, we can say that this pod has a certificate and all kinds of tricks. We have to trust Kubernetes first, unfortunately.
Or fortunately, it does mean it's your single point of failure.
Yeah.
But also it means you have a single point of failure. Just one.
I mean, try doing these kinds of identity things without Kubernetes. It just becomes like you have to start dealing with like the hardware weird stuff on nodes to give you nodes identities and then build it up from there. And it's really, really hard to do this. So what you get from a cloud provider and with Kubernetes is so helpful to be like, this pod, we know there's this service that has these labels. This is just so helpful. And yeah, this is what I would recommend building these kinds of security tools on top of it.
So you mentioned that for a bank, you don't want any service to go willy-nilly and transfer money. So like, what was the goal you set out to achieve, like when you thought about this?
Yeah, so we started out with just looking at one service, which was called the ledger, which is basically just the final point of truth for what money is where. And we kind of thought this is something that actually quite a few services have to talk to. This makes sense, but by quite a few I mean like 100, and there was like 2,000 services in total, and some of those services do very frivolous things, and like they might show the photo on like a account, so they show like the photo you've associated, and they just retrieve that from S3, and this is not something that needs to be able to move money. So the really simple problem we wanted to start out with was that. But that kind of expanded a bit for a general PCI goal of cardholder services. These are services that have card-related information flowing through them, which is also quite a lot of services, like over 100, I think. And they should not be able to interact with non-cardholder services in the sense that like they should sort of infect other services. And like if you're talking to a cardholder service, you need to very carefully make sure how you talk to them is right, so you don't leak cardholder data. Otherwise that becomes you, and you become a cardholder service. So this is kind of how PCI works, and this is actually a problem that like so many companies have to deal with, and it's quite hard. So that was our sort of medium-term goal. The short-term goal was just sort this out with the ledger, come up with a list of what services can call it, and have that list be reviewed by the team that runs the ledger so that they can ensure that there aren't any new calls happening that they don't know about. And that's not so much a security control because we do trust our engineers, but that also just gives them the ability to just keep track of who's using their service and make sure that they're doing it right and review it and things like that. So that was that explicit goal as well.
It's an operational tool, right? But it's not just about, locking things down. You gotta also make it possible to work while things are locked down. Otherwise, people start looking for workarounds. And it's like what you said about people get hacked because of that service, which is kind of has been forgotten and does this really small thing because somebody needed to do something and actually nobody really cares about it. And that's why they also didn't pay a lot of attention to it security-wise, because it doesn't seem important.
Absolutely.
But it's there, and it has access. We might not realize.
The post-incident review or something like that. Yeah, exactly. Yeah. So we needed to make this like really simple and also achieve goals outside of just security. And I think in general, if you want to persuade engineers to do secure things, you can try and give them something. And in this case, this ability to review and also just know who's calling you. Because the nice thing about security rules is that they give you this exhaustive list of who's calling you, right? Like because it's being enforced, we know that the total list of callers must be less than the list that are allowed to call. And this is a really useful strategy just in running an engineering organization, just to understand the relationships between teams, the contracts, and these sorts of things. So that was definitely a goal.
Right. Even finding out like if this service is down, which services are being affected by it, and you don't need to wake them up because their incident is caused by this and not because they're actually down. Like you don't need to wake up 12 people, you need to wake up one person.
Absolutely.
There are a ton of uses to that sort of information. It's no wonder that observability is so popular. People are trying to find whatever way to get whatever they can to make the right decisions.
Yeah. So, I mean, trying to understand these links between services kind of as a black box, using observability, using monitoring, using metrics, this was actually a big part of our project. And it's actually really hard. Like, there's so many different ways that services can communicate. And, you end up having to do kind of deep packet inspection, essentially. And this is just a really difficult problem. So, yeah, it's something we spent a lot of time on, because to be able to safely identify, even just with the ledger, which services should be able to call you. Okay, you can look in the code, you can look at imports maybe, but you also need to look at low level, like you need to look at the network traffic and somehow get metrics for each service and which calls each other service. And yeah, this is hard. Requires a lot of investment in monitoring.
Yep. So tell us a bit more about that, right? So you said you had about 2,000 services, only about 100 of those or so. I guess at when you started, that was a guess you had, that's more or less the scale. Now you're faced with the task of figuring out which services do and don't need to call the ledger, and also building tooling to operationalize that. So what's the first practical step you did, and like what did you learn from it?
Yeah, so I think we started I think just by looking at some metrics from our service mesh. We had kind of a home rolled service mesh that used Envoy, and this gave us a pretty good idea of what services were calling the ledger. And we knew that the ledger is not an unusual service. It only receives requests over HTTP to a particular port. And this really narrows the complexity. So with that in hand, we took this list from our metrics, from these Envoy metrics, and we enforced them first in staging, and then we eventually went to production. And we had this list of services that I think at the time we just put in the network policy that kind of lived next to the ledger service. And this already achieves some of our goals, because this means it's reviewed by the team that owns the ledger. So they're like the code owner. The downside is like it's this weird network policy object that team wouldn't normally be dealing with, and they have to manually update it. And other people writing new code that calls the ledger, they may not know about this, and they sort of might be confused as why their services can't reach the ledger, which in a sense is like the rule being enforced. I mean, this is good, but they may have a legitimate reason to do what they're doing, and they have a way of sort of figuring out what's going on, have some breadcrumbs to do that. So that was the initial problem that we had. It was just a bit confusing and difficult for everyone to manage it, both the team that owned the service that was being called and the team calling the ledger. Everyone was just a bit like disconnected, I guess.
So sounded like first attempt worked. You had like a pretty well-defined problem, the tools to map what needs to call. But worked is a bit of a vague word, because it worked on a technical level from a security perspective, but the usability of it sounds like it wasn't great. Like it created a interdependency between teams, which you wanted to have, but for new teams to discover, or new people who need to talk to the ledger, or who haven't worked on it yet, to discover that this is something they need to do, you basically had to document it pretty well, and it's a pretty large organization.
Yeah.
So I guess you end up having like a constant stream of people who are confused about what to do. Once you pass a certain point.
Because it was such an unusual service to be, well, reasonably unusual, and generally you would be talking to the owning team, but we knew that this would not work in general for a few of the reasons I mentioned. So, obviously it's true that there's this disconnect between teams, and it's just not going to work when you have to do this for every single call to every single service. Like, this is generally something that the calling team should be able to own. It doesn't necessarily have to be reviewed by the owning team. The called services owner, they may not care. It's some random service. And also some services do unusual things. They may be on the edge, so they may receive network requests from like public IPs, which wouldn't sort of be encapsulated in like a name of a service. And they may talk to each other over different ports or other weird stuff. And I think what we ended up finding was, like, over the whole project, almost all of our time and energy was spent on the like 5% most unusual services that do weird things. Every service that was just like an HTTP server talking to other services, this was really easy. Like, one approach that fits all of them. But the other ones, finding those edge cases was really hard. So what we did is we kind of built a set of tools that we sort of iteratively built up on top of each other to catch more and more of these edge cases, to find more and more services calling each other and start to piece together this list of what services do. And originally, that was with the intent of just managing network policies in the called service. But eventually we started to realize that doesn't work. Engineers shouldn't have to look at a network policy. Ideally, they're pretty complicated and weird to look at.
Why? Tell us why.
Well,
You made it sound very...
They don't have a sense of a service identity. They deal in labels, pairs of labels. So a label of the receiver and a label of the sender, and then ports. And product engineers, they don't necessarily know what labels a service might have. They may not even know what ports a service might go on. The thing that they care about is that these two services identified by their identity call each other. And this is just a higher level concept that we knew we were just going to have to build that. We want service people, like product engineers, to just say the name of the service that they want to call and write that somewhere in a simple way, and for that to be able to call the receiving service. So that was definitely a goal. And the other goal was to be able to automatically figure that out just from the code that they've written in 99% of cases.
This is a tool for that, right?
Yeah.
RPC map.
We made and I get asked a lot, like, can I have this tool? No, because this will not work in general. Like, this is an intractable problem in general. If you're dealing with cross-language calls, it just isn't going to work. Maybe you can make it work for gRPC, but again, it's a hard problem. The reason it worked for us was because in our organization, there was an extraordinary level of uniformity. Almost all services were written in Go with a particular RPC framework and would do their service calls in a particular way. And this made it very easy to write code analysis tools. So a code analysis tool could scan the code, look for what looks like a call, figure out what service is calling, and this worked for a vast majority of cases. It was only if you were doing something weird. So if you were, like, for example, getting the service name out of a list of service names or like out of a hash table or something, and then putting that in dynamically, the code analysis wouldn't be able to figure that out. Kind of could only figure out string literals for services, I guess. Those are very, very unusual things. And obviously we were going to have a strategy to find those cases, but maybe we'll come on to that later. But at least for the normal case of just services talking to each other, this worked really well. So we were able to immediately come up with like a big list of rules. I think in the end we had like 9,000 different connections, as in like service A to service B is one connection.
Well, I guess that makes sense. That's like, if you divide it by the amount of services, that's like
yeah. In theory, it should be quadratic, right? So in practice, a huge number of services only talk to like two other services. I think there's services for authentication or authorization and like one or two others. This is most services. So, and then there's like lots and lots of services that call two others on top of that, and then a very few that have to call many. So it's actually not quadratic, and it actually doesn't scale too badly. But yeah, I mean, we that was really nice to have that tool. And the goal then was to put that tool in the SDLC, as you mentioned, and essentially try and maintain these rules without engineers thinking about it, unless they're doing something weird. But we also had to find all the cases where there was already something weird running in production, and we have to go and figure out all of the rules that the tool wouldn't find. And yeah, to solve this, we had to look at the network level. Like I mentioned before, you have to basically packets. We managed to benefit from a couple of the tools we were already using, Calico being one. Calico, the way that it works, when it drops packets or when it would drop packets, certain breadcrumbs are left for you in the packet counters in the kernel. And we wrote a tool that can kind of look at all those counters and kind of figure out what could have happened. And this eventually allowed us to essentially have a situation where we know that if the packet had been dropped, we won't drop it because that would be bad. That would break things in prod. But if it would have been dropped, if we were enforcing, then we'll know. We'll know from metrics. And we knew this at the granularity of services that packets were being dropped coming to. So we didn't know the full connection, but we could kind of identify services that were weird. Like these services, someone's calling them who we don't know about. And then usually once you know the name of the service, you can go and figure it out. So this was the main way that we solved it. And it wasn't difficult to build, but it wasn't a generalizable approach, sadly. It had to be built specifically for Calico. And I think it's on GitHub right now, Calico Accountant, it's called. But I don't think it works anymore. Sorry, it's a few years old now. But I'm sure something similar would probably be buildable for most platforms.
Yeah, probably from the stats, or I guess it wouldn't work with anything that doesn't use IP tables under the hood, because I guess you were kind of looking at those counters, so it probably wouldn't work with same approach, wouldn't work with Cilium or AWS VPC CNI, but
I think Cilium has some kind of similar approach where like the eBPF can do counters, and also with the eBPF you can also put in logs and all kinds of interesting stuff. You can kind of do arbitrary things. And Calico also had a logging mechanism where it creates kernel logs. But this is actually a bit scary because if you send like thousands and thousands of kernel logs per second, your kernel will not work. And this did happen at one point. So yeah, this requires extreme caution. So what we would do is you would make sure that the packet counts, like the dropped packet counts, were really low using Calico Accountant. If we just couldn't figure out where it was coming from, we would turn on the logs, and you just get a few log lines out, and the logs would actually say like the source IP, the destination IP, what was dropped. So it makes it way easier to figure out like where's the weird traffic coming from. And then for each one of those cases, we would make sure that it was represented in some way in the declarative rules. So either you can sometimes just put comments in the code, and our RPC map tool would pick those up and like comments and turn them into rules. So this is the best way, because then you can kind of put it near the weird thing that you're doing. But if it's like something that doesn't, like for example, if it's the service isn't written in Go, which we had a few like that, then you just have to sort of define somewhere else like a manually specified rule, like this is a special case and this rule is required. And those ones are the scary ones because they don't get removed. They, like you were saying earlier about DNS records, they sort of accumulate over time, that no one's really in charge of removing them. And this is slightly the cost of doing business when you have manually maintained rules. But that's why we've wanted as much as possible to be managed automatically. And your pull request can get approved if the tool thinks that a rule should have been removed or should have been added, and that keeps them reasonably in sync.
Yeah, it's important for it to be mostly automatic. Otherwise, you're going to get a lot of pushback. Because if it's mostly automatic, then it's a tool that enables progress. If it's a lot of manual work and requires understanding, like how network policies work or what can you see with Calico, then you can get 10 people to do this. Getting 500 people to do this is very difficult.
Yeah, exactly. And you don't want people to resent the security organization. For us, it seemed like we're slowing things down. So yeah, I mean, what we wanted was for you to kind of not have to think about it at all unless you're doing something unusual. And if you're doing something unusual, you wouldn't be too annoyed about being slightly slowed down. For example, you don't write a new service that receives traffic at the edge from public internet very often. That happens you might do that a couple of times a year at most. So you wouldn't be too upset about this. But the typical case of I just want to call this other service, this is not something you should worry about at all. But we did want, in principle, all of the rules to be visible at PR time. So maybe someone can have a quick scan why is this calling this service that maybe I see no reason why it would be.
So not after the build, while the PR is open.
PR is open, yeah. We wanted that at least to be visible to the humans. I mean, I think in practice they kind of scroll through them a lot of the time. But the really strong control that we had is that we had it so that you would be added to the review if you wanted to be. If you had a service that you thought was high security and someone was calling that, it would bring in the team that owned that service. And this was an optional behavior, but a lot of the teams doing core financial systems did that. And this is really important property. So most of the time, no one really minds about the rules. The main thing is that they reflect what's in the code, and that a compromised service couldn't do anything in addition to the rules. But in some cases, like for the ledger, teams actually really did care about who was calling them. They cared about the human aspect as well of are they doing the right thing? Should they be calling us? And for this,
that's threat analysis, right? Like with a service like the ledger, you need to worry about a bad actor. With a service that sends logs off somewhere, probably not as much. And you also don't want anybody to ask you if they can send logs. Of course you can. That's the point.
Having a system that sort of has different levels of security and caution depending on how important the service is. I think this is really important when you have so many services, because otherwise you kind of encourage people to just bundle things up into existing services. So let's say that I have like a platform service that's for all of the things that the platform team needs to do. Probably that's going to be a very privileged service that's going to be allowed to do all kinds of dangerous things. It's going to have like AWS creds and it's going to be cool and everything else. And then it might be really tempting that when I just want to send some logs somewhere, like you suggested, I could just put it in that service. I don't have to get any new permissions or any new rules. This is a really common security anti-pattern that I've seen all over the place. And what you want is for it to be as easy and as low friction as possible to add new services that don't have much privilege. And then you'll have lots of services that don't have much privilege. And that's great. Lots of services that don't have much privilege is like amazing, because you can just put them in like a box. You don't have to worry about what they can do at all. You don't want to have services that have loads of privilege that also have lots of frivolous things inside of them. This is really scary, because that's maybe how you get
it. It's like it's the utils package in the code. It's like it's a little bit hard to think about where to put something, and once you have a utils package, like stuff just starts piling up and down.
Yeah, exactly. And like I guess the way that we see it, and PCI, to its credit, also sees it the similar way. Is like if you're a service that does something dangerous, like deals with card information, then we should be thinking incredibly carefully about what the service does, who calls it, what are the data passes through it. It requires a lot of caution. So bundling things together because it's easier to get through security review that way or whatever, this is really bad. So this is a really nice property for us, is like encourage the continued expansion of lots of small services that don't do anything dangerous. And that was already what Monzo was doing. That was like a very Monzo approach, like just make a new service. There was literally a single CLI command to make a new service and then another CLI to deploy it. So this is like how you end up with 2,000 services. And I think it's probably like 5,000 now. But I actually thought that was great. And like each one of these is like 2 pods, 3 pods, it's a very low resource cost. But from a security perspective, it was really nice because these services were immensely locked down. Like typically they could call 1 or 2 other services, and this is great. So yeah.
Yeah, I think you're exactly touching on the connection between platform and security, because the platform team's goal is basically allow the development team to move faster through the use of the platform. But they also have another goal, which is, and nobody will destroy the company by hacking us and stealing all our assets and our data.
Yeah.
Because it's really easy to make it trivial to progress, right? You just do one big service, give it permissions to everything, give all the people in the company root access to everything, and then anybody can do whatever. And as long as they coordinate, which isn't that simple, you're gonna make progress. But then you're gonna get hacked, or you're gonna blow up the world like CrowdStrike through bad processes.
Yeah. Got to be able to vary your amount of friction quite cleverly. And this is quite hard, to be able to tell the difference between a service that actually needs to be carefully looked at and a service that doesn't, when, from the configuration perspective, they're just services, they just run code, they may look identical. So that's something that we sort of slowly developed over time, the ability to differentiate between those two. And the way that we did that was essentially through these code review processes. That was the
You basically let people opt in to my service. Like, I want to know about new callers to this service, or this service requires more stringent review, versus the default for many services, which is as long as you declare what you need, it's gonna work.
Yeah.
And I think it's true that tweaking the amount of friction that you provide is difficult. Because for something that's risky, you want to have a bit of friction. Like that may be a boon, because you want people to take a moment to consider what they're doing and not do it because it's the path of least resistance, which is kind of what happens with those big services or the utils package.
Yeah.
And like one way to do that, if you add friction to something that's risky, you got to make sure there's an alternative path that has less friction, that is the right path if it's the non-risky service. So you got to make it really easy to spin up new services if you don't want people to bundle things into sensitive services.
Absolutely. And you really do this by tightly collaborating between platform security, or in our case, basically they are the same team. Like you can't have on one side a team that just cares about making it easy to spin up services, and on the other side, a team that just makes it easy to make services secure, it can only make sense to do those things together. Like, we need to make it easy and secure for people to write new services and for them to do the right thing. You have to look at it as like a holistic problem, I guess. I thought Monzo did this really well. And yeah, I guess for me, the right way to do it is to just make sure that your platform team know that security is their responsibility. Like, of course it is. I mean, it's not a responsibility you can outsource to someone else.
Yeah, I think everybody knows it on some level, but there's lots of different kinds of pressures in a big organization. And like an organization with a good platform culture understands that the way to make developers cost less is to increase their velocity, and that bad security also decreases velocity just a little bit later. Because you get an incident, you realize that you failed an audit, an internal audit, an external audit, and now you need to fix things, and you're like throwing your plan in the trash because now you got to take a couple months to change everything and do it with no downtime. The problem is those prices can be hard to see at the level of like I am an IC like doing something right now, even in the platform team. Like really, I think that's where we talked about technology earlier, that Kubernetes has made things simpler. I think it's hard for humanity to like collectively remember these experiences, except for very many years. But technology is the way we remember. So when we build things like what you built at Monzo, and wink, wink, what we're building at Otherwise, removing the need for every individual IC to be able to see all of the collective problems that can potentially happen that they don't want to happen, because their goal is to improve velocity, and those run counter to that. But it's too much to think about. Like what Kubernetes does great is it removes some of the things that you need to think about, and that lets you think about them a bit deeper.
Yeah, it's guardrails, and that's what we were trying to come up with as well. And at the time, it just didn't really seem like anyone else was trying to do the same kind of guardrails as us. I think maybe Otherwise is, but at the time, that was how it seemed, and we wanted there to be like a really intuitive abstraction that engineers wouldn't really think about once it existed, just the essence of how the services interact. And we had plans to expand this to be other types of credentials as well. I mean, this general idea of a service declaring what it can do, this is really powerful. But yeah, while I was at Monzo, we got as far as doing network egress, so like which services can talk to GitHub, which services can talk to Google. But that was as far as it went while I was there.
And I think, like I can tell you from Otherwise, that there's, on the tweaking the amount of friction side of things, there's some power in looking at other kinds of access. So fortunately or unfortunately, there are non-optional types of authorization. Like when you're using AWS, you gotta have AWS IAM policies or security groups to access things, because the default is you can't access anything. And I'll be honest, they haven't really tried to make it easy, which, I mean, it just doesn't seem like that was the goal. The goal was flexibility and power, rather than making them
policy where it's these low-level tools that allow you to represent a huge amount of different configurations and end goals, but it's not something that you want product engineers to be configuring. And yeah, if you have lots of services that need to talk to AWS, it can become an extremely difficult task for sure.
Yep. So if you look at the abstraction for what a service needs to talk to, and you don't just think on the network level, but also on the cloud provider level and other external services, and some things an engineer knows they have to do on some level, maybe if the organization is big enough, they have to have a meeting with an SRE and they do it together or something like that. But their service simply won't work if they don't take care of that. If you can give them a tool to say what they need versus how they mean to do it, which is what an AWS IAM policy is, it's how and not what, then if you can then bundle that up with things that would normally feel restrictive, like network access policies, and the overall experience for the engineer would be, oh, cool. So I just said what I needed and now it works. Kind of like how people think about it for Android and iOS apps, right?
Yeah, like capabilities. Yeah,
you say what you need, it works. You didn't configure SE Linux, you didn't create a user, you didn't chmod anything. Just works.
I definitely think it's more intuitive when they, as you say, when it's resources that engineers don't kind of expect to have. And sadly, we live in a world where the norm is that services can all talk to each other. And this is a really hard cultural thing to undo. But at least it is true that you don't by default get access to AWS. But you often do, let's say, have access to like a database if it's running in Kubernetes.
Yeah.
A hard problem to solve. Often people run like Kafka in Kubernetes, and usually, typically, every service can talk to that. So all of these things need to be individually addressed, and yeah, ideally all in the same way. And that was kind of our vision, but we never quite got there by the time I was there.
Yeah, well, it was an awesome vision. I remember I read the blog post and I was like, wow, this is so well written, and it's like it describes your journey. So probably this is a good point to zoom out a little bit, and can you explain what the final workflow you ended up with looked like? What does it look like to be a service developer at Monzo when you're working with the system?
Yeah, so I guess let's say you start from creating a service. Like I said, you can do this in one command. This is going to create like some boilerplate, like some basic handlers and things like that. And if you write a handler that just calls some other service, this should be caught straight off the bat as a pre-commit hook by this tool called RPC map that we mentioned. So this is going to identify the service that you called, and it will create this thing called a rule file. And the rule file, we had many files. So we had a directory in each service, kind of subdirectory, that contained just empty files for each service that you wanted to call. And the singular reason for this, instead of having like a list in a YAML file or something else that probably would have been more intuitive, it was solely because this allows you to hack the GitHub code owners mechanism. Because if you have the file is called service.ledger.rule, then you can set up code owners that it controls and looks for files called that. And if we instead just used a PR bot, which probably is how I would do it today, then you can have the same goal using like PR bots for approval, which I think are much better supported by GitHub now than they were then. But at the time, it was like really annoying to use anything but GitHub's like code owner mechanism for doing approval.
Yeah, I mean, I can also see like why do that when you're iterating, right? Because you see a problem, your current solution isn't very far from being able to utilize a possible solution, code owners. So that's a natural next step to just test it out.
It felt very clever at the time, but then we sort of later realized it doesn't expand well. So like if you want to expand the abstraction to Cassandra credentials, for example, it doesn't work for that. We managed to extend it to like github.com.rule and things like that, but it is only so far you can go with this. At some point you need essentially a config file, unavoidable, but it worked for us. So these are the files that we were using. So if you were calling the ledger, this would add an extra reviewer to your PR, but typically you wouldn't have anyone other than just the person in your team reviewing the code. And they ideally would scan through the rules to check there wasn't anything crazy. But the PR bot would also validate that the set of rules is what the RPC map will identify. So you can't just like sneak in a service.ledger or something, or sneak in some other service. It should be reflected by auto generation from the code, unless you set up some particular exception that was very unusual.
Those weird services from earlier.
Exactly. So this is the basic approach that we took, and that's pretty much the extent of an engineer's interaction with it. As long as their pre-commit hook ran, these rule files were created and they got approved and they got merged, that's it. And then, the rest of it was the platform team's responsibility. That was the kind of the contract between product and platform. Like you were saying, you're asking for the resource and you get allocated that resource. In this case, the resource was the ability to talk to this other service. What we then deployed that as, in principle, we could change, but the way that we were doing it at the time, at least, was by taking each of these files, labeling your service with different labels, saying the services that they're able to call, and those labels would then be kind of give you access through network policies that select on those labels. So if there are some network policies saying, I am the policy that controls access to the ledger, all services labeled with ledger, I'm allowed to talk to the ledger equals true, then those are the services that will be allowed to call it. So these labels become the sort of core mechanism. But that's just
why not?
Why
not have a network policy for each caller?
Well, you absolutely can. It just felt like it was going to be too many network policies. I've looked through the Calico code, and there's lots and lots of cases where you just iterate for every single one, and you build up like a total rule set. And I didn't really think it was a good idea for there to be 9,000 of them. So instead, we have 2,000 of them, one per service. But also, you need to when you're on a particular node, you need to assess all the network policies that could apply to traffic coming into that node. And it's a lot easier if there's one per service instead of one per calling service. So the whole thing felt a little bit, I guess.
Imagine there's also, so Calico is implemented using IP tables. So I guess essentially what a network policy on Calico probably boils down to is a rule that looks at the IP address of the destination, which is the server pod. And then if you have one per pod, basically very quickly it can short circuit to these are the rules I need to evaluate, and I don't even need to look at the others because they're restricted to other pods. And then if you had one per caller, you'd probably have like an order of magnitude more, which might be 10. It sounds like.
Yeah. I think that we had, I think like Calico translates a given policy. There's a little bit of boilerplate around just the core rule, which is like this source IP and this destination IP. And the boilerplate would be magnified by the number of policies. But if instead you have one that selects lots of calling pods, you can end up with there just being one rule per calling pod. And that's a lot better. I mean, you can't do better than that with IP tables, really.
Yeah. And I think like what matters is it worked at that scale.
It worked at that scale. Most people don't have 2,000 services with 9,000 connections. So it wouldn't be a concern for them in any case, and pretty much anything would work. But I mean, I guess one of the cool things here is that like we are essentially a compiler now. We're compiling rules, which is an abstraction that makes sense to product engineers. We're compiling them into Voodoo, Kubernetes, Magic. Doesn't matter how we do it. And the goal was always that one day these rules would be enforced by other means. For example, end-to-end TLS, we can have certificates on both sides, and you can actually do application level filtering, not network level, but you can say you do not have a certificate for the calling services.
Yeah.
I think that has been implemented since I left, which is really cool.
Yeah, you could probably ambient mesh, and like with today's tooling, could probably translate into authorization policies for an ambient mesh, and then as long as you have those in every pod.
Yep. We also did MVP with Istio. And basically, you can compile these rules into anything you like. They represent kind of fundamental property of the platform, something that a service needs to be allowed to do. That's actually independent of where it's running and like the particular APIs available. So that was a really, really cool property. And this is actually handled by the build system. So there was already a system that would obviously build a container and then also come up with the manifest, which originally would have just been put the image that we just built into this field here of the manifest. This is the deployment and then deployment update. But we added on a step to be like, okay, and also take the rules files and figure out what labels the pod is supposed to have and create those labels, put those labels into the pod. And that was done on every deploy. And the other really nice property of this is that it's rollback safe. So because so this is actually a really hard problem in network isolation in particular, but I guess in general with credential management, if you deploy any aspect of what a service is able to do, whether it's its AWS credentials or networking, separately from the code that wants to do those things, then they can get out of sync with the rollback. So let's say that you take some permissions away from the service, that they're not needed anymore in the new version of the code, and then you roll back the code, and it will be trying to do stuff, but the sort of rules haven't rolled back. So this was really important that it all goes together. By using labels, we have kind of Kubernetes' guarantee of that like the label is packed in the pod. If the pod is running this version of the code, then it will also have this version of the labels. Now, I don't know if that
client pod, right?
Yeah, the client pod. Exactly.
It's the client. That's what really caught me about the format. So you ended up having files, a format where all the files are kept together with the client.
Exactly.
For the rollback safety and the responsibility.
Deployed all together. So if if you have any extra manifests, like for example, network policies or anything like that, it all needs to go together, but also the labels need to go together. And when you do a rollback, you need to roll back the whole set of resources. And this is why actually you can't use like the Kubernetes kubectl rollout undo type things that will just switch back to the old replica set. You need to make sure that the whole package of like artifacts, all the manifests, they all need to go back to the version before. And there are still some hard problems here because most of the time Kubernetes will not guarantee that like the old resources can only be used by the given pods. It really depends on the use cases, but at least labels, and most of our stuff was working just through labels. And therefore, when the pod gets rolled back, the labels are guaranteed to only apply to the particular pod of the particular version. But this is something that really we put a lot of time into, because part of having a very high deployment rate, we're deploying hundreds of times per day, you need to be able to roll back services very rapidly and never ever cause a bug where the service is rolled back to a version that now has some issue because of network policy. So this was something we really, really needed to crack, and it's one of the aspects.
If you do hundreds of deploys a day, then as soon as you have a single problem where sometimes somebody needs to manually intervene, you will go back to 10 a day.
Exactly. Yeah, we can't do anything that slows down the rollout process. It was such an important part of our engineering culture, and part of that was just rollbacks being just not a big deal, not like a emergency break glass thing that required a lot of care, but like this will always work. This is definitely going to get them back to the state that they were in. And yeah, this kind of declarative rules approach, this is a huge part of how we achieve that, because otherwise network policies would be a really difficult thing to maintain.
Yeah, because just going based on that, so the network policy would be on the server side, potentially in a different namespace, different Helm chart, and the configuration files would be on the client side, like all the labels. So you gotta make sure that you sync the labels and the version of the code with the version of the network policy.
Yeah, exactly. Yeah. So by just I think the thing that we thought was clever was that you basically don't have to change network policies almost ever, because they just say, I'm the ledger network policy and I allow pods that are labeled, I'm allowed to talk to them. That never really changes because that's sort of given as true always. Yeah. So then really the only thing that changes between a rollout is just the labels on the pod. Now, if we had to stage the deployments on both ends, like you have to do something on the ledger deploy and do something on the client deploy, and then you have to roll them back together, this is just complete no-go. Ideally, there would never be rollback dependencies between services. In practice, there usually are when you do like API spec changes and, about fields being removed or added, but at least we didn't want to add new complexity there. So the goal was only for the client. The client is the only thing that needs to be deployed to have this change in the rules. And it could be rolled back as an atomic unit, essentially.
Right. So once you had rolled out to the entire cluster, you had basically a static network policy per service. But while you were rolling out, you were in this sort of interim state where you could have had a network policy, but you weren't really enforcing. And the thing is about network policies, once you turn on the enforcement, it blocks everything that doesn't have the right label. Like a network policy can't selectively block. Like you couldn't make sure that you block everything that shouldn't call and then check that it's fine. So that at least during the rollout, which for a big enough company might be forever, you got to make sure that you're able to roll back, right? Both the network policy and the configuration file on the client side. And going back to friction, right? You got to make sure that achieving that, completing the rollout and, taking the steps you need to get to 100% coverage is easy enough. Otherwise, you're going to try to find ways to sidestep it. Maybe let's just, restrict the scope to here. But then this service is able to call this sensitive service, and it itself is not protected, so everybody can call it, and then there's a vulnerability. I guess it all comes down to how much you want to do to prevent threats. And like, where do you draw the line in terms of, okay, it's now unreasonable for a breach to happen, or we've practically prevented it except for this area where we have human controls. That's another solution, right? Like I mentioned, the HR in the beginning, you might not need to solve that one with technology.
I guess for us, it was just about getting the risk down to below other things that were then become a better investment in time. So, for example, once you have some kind of basic zero trust controls, you can move over to observability, monitoring, alerting, human controls, like you mentioned. There's always, especially in a bank, there's just unlimited security projects that you could work on. Our goal was to get this to the point that it was no longer our biggest concern. I would say that the starting position of like every service can talk to the ledger, this was 100% the number one, like most significant security concern in our platform. And once that wasn't true anymore, that was a good thing. We were all sleeping better at night.
Yeah, because you're always thinking, what happens if our test doesn't pass and CrowdStrike crashes everything or somebody steals all the money? Once it's possible, you can't sleep well at night.
Exactly, yeah.
So we're about at the end. Well done. It sounds like you had to build several custom tools to get to a point where operations, security, and service devs were all able to achieve their goals without tons of friction. And to me, it sounds like you were successful. So looking back, would you say it was a success? How did service developer teams react to this new tool that they're now basically forced to work with? Did they see it as like a benefit? Did they hate you?
Yeah, so I think, I definitely look back and I see it as being successful. I know that it was used for years. I think that the underlying implementation of how the rules are enforced has changed, which is also in a way a huge success, because it's like that shows that we built something like an abstraction that actually works, that makes sense, that actually abstracts. I remember like mild irritation from some teams when we first deployed it. It was just a thing that they had to worry about. They didn't before. And I think also there was a little bit of confusion about the security model. For example, like some people kind of saying, look, if no one's really reviewing these rules files, then what is this achieving? Most people aren't checking one against
engineers being demagogues.
And that's just a security model thing, whereas like we actually kind of trust the engineers, or we at least trust the code analysis. And the important thing is that the service can only do those things. And that's a little bit of a different way of thinking about security, I guess, that was just a cultural thing to get across, I guess.
Yeah. Well, I get that a lot of people might ask that. Wow, I'm very orange. The sign is like over there. I can see it. And it's very orange too. Anyway, I get that a lot of people could think that how do you trust the engineers to review this? Because wouldn't the security team want to review this? But then you gotta consider two things. One, you regularly trust engineers with other things that are just as production critical. You trust them with the code, that once they review the code and it goes through the process, which is the process has been approved, then it's fine for them to deploy to production. You don't have somebody from the security team reviewing every line of code, and it's just as critical, right?
Absolutely.
And then like once you do that, and you also take into account that a lot of even older companies have started to view engineering organizations as less of a cost center and something that can pull the company forward, then it makes sense to invest in their ability to move faster and to put trust in them. And you're not putting trust in each and every individual. Sure, you're interviewing them and all that. You're putting trust in that you've established a process that keeps things running well, just like you do with code. And I think that's really key about what you said, where when the deployment and the review for these files is together with the code, you're really doing that because it's the exact same process, and you trust the SDLC.
Fundamentally, it's just the same as code. I think that's the right way to think about it. Ideally we can derive these things from code, and also we can deploy them with code. We can roll them back with code, and we have the same amount of trust of their production and their emission as we do with code. I trust engineers to create code that affects how their services do stuff most of the time. And sometimes we want extra review, but basically we're trusting them to do that. And that's the same with these rules. But the thing that matters is that is the thing that they've written down, that is what the service does. That was the main thing you want to enforce. And before a service can call 2,000 other services, and after it can call whatever is the list. Even if your list is really bad and it's like 100 services and you actually need to talk to 5 of them, that's still better than 1,000 or 2,000. So that was kind of the thing we wanted to get across. So I think that was really the only the only thing. I think there was early on, there was a little bit of confusion, like, well, like, am I supposed to be checking each of these? The answer is basically no. But I think broadly, people thought it was a lot lower friction than pretty much any other approach to solving the problem, which was good. And yeah, I think it had a lot of longevity, and I think people became used to it pretty rapidly, and it worked. So yeah, it was. I would definitely say it was a success. And we, like I said earlier, we expanded it to be network egress, and we had plans to do more. So yeah, I think it was the beginnings of something kind of exciting.
It is. It was. So, questions. Do you have a hot take that you'd like to share? It's the best it's the best part of the podcast. People say crazy things.
Yeah. I mean, I touched a bit on this earlier. I think basically separate security teams can be a really damaging thing. At the very least, call it platform security, but I would probably instead make sure that your platform team know that this is a core responsibility of theirs. That will lead to some chores, things like PCI that they would just really rather not deal with because they're often on paper exercises. But no one is better placed to actually assess whether a PCI control is really enforced than the platform team. You know, you can ask a security engineer, okay, is there isolation between cardholder services? And they'll say, yes, because we have a policy that says that it is. And you can ask a platform engineer and they were like, oh, well, yeah, but there's this one service and, oh, I could probably get around it if I did this thing. And they'll think about it like a platform engineer. And that's the way you want to think about security. You want to think about like, what's the loophole? And that's how your attackers are going to be looking at it as well. They won't actually, this may shock you, they won't read the policy and follow it to the letter. But instead,
this organization has a policy. We can't act them.
We can't take the security policy. Instead, they're more likely to be like, okay, well, how do I get the cardholder data? I'm going to do anything that I can to make that happen. And I think that's the right way to think about security. I think that can often lead to very different conclusions than if you looked at it from a more traditional view. And you may end up having to do things that are unorthodox and persuading your PCI auditor that you've done the right thing. But I have found that works. And I think that it leads to much better security outcomes overall. So yeah, I would say as much as possible, try and merge the responsibilities of core platform architecture and security architecture, essentially.
Yeah, I think we're definitely, there are several factors pushing us there. So first, just the existence of platform teams and this new kind of thinking about engineering organizations. And also that it's no longer optional to secure stuff because crazy shit happens every week. Yeah. So it's not like, but nobody's going to attack us and it's horribly convoluted. No, because it is convoluted.
We've seen with CrowdStrike, I mean, not to dump on them, but like you can't just offload it by just installing some software on your computer and being like, great, job done. The green button has been pressed and now we're secure. Like, I think we need to make sure that everyone has the tools to make things secure, but the only people that can do that that can use those tools are the engineers writing the code, the product engineers, but also the platform engineers that need to create these platforms that allow people to build secure products. We're all responsible, can't be offloaded, can't be outsourced, unless you want to panic every machine in your organization. Maybe you do, but I would say
we can't ignore it. We can just build better tooling to make it nicer and help us move faster.
Absolutely.
I think people they'd rather not think about security. Security used to be this oppressive thing where the security team would tell you what you can't do, and then you try to find your way to do stuff anyway because you had to. But now it's more like, how do we get things done securely because we don't want to be the next whatever company that gets compromised.
I think engineers want to write secure code. I've always felt that way. I think that it's important that they have time allocated in their roadmap to do that they don't feel that that's some other team's job. Oh, they'll do the security review, and if they approve it, then I'm all good. That I'm absolved of responsibility, even if I wrote the most horribly insecure code. If they approve it, it's okay. And I've really seen that thinking in real life. And I think it's very, very dangerous because if people know that it is their responsibility and it is kind of on them and the buck stops with them and no one else is doing it for them, then they'll take it seriously. And, this feeling of being kept up at night a little bit by oh, this thing is actually really dangerous. that's kind of a good thing. And it's something you want to encourage in your engineers, is that they feel to some extent personally responsible for the security of the software that they own. I mean, insofar as they also feel responsible for its uptime, they also feel responsible that it functions, and the security is just like that. So yeah, I'm keen on encouraging that feeling of responsibility in your organization, and giving engineers the space to implement it and the tools and investing in those things.
Yeah.
Easy.
I think security used to be more of a compliance thing, like something you did to check the box. And you still have that, right? But sometimes it's not enough anymore, because you get that nagging feeling that, we passed the audit, but we also found out that maybe we shouldn't have passed.
Absolutely.
And now you gotta ask yourself, like, do I do something about this? If I reach the conclusion that it's a reasonable threat, I should probably tell somebody and fix it.
Yeah. And that's how we approached PCI, for example. We just thought, let's use this as an excuse to make our platform way more secure in the spirit of the audit, even though we probably could have passed the audit just by installing like a firewall appliance or something and being like, look, we have a firewall appliance, so now everything's fine. But instead we were like, no, let's actually go and build the thing that we kind of should build to actually make these problems secure. And if you look at all of the compliance things through that lens, they all are sensible things. They often say sensible things in the language of like 1990s software, but they are still saying sensible things. Services isolated is a good idea. So it's a good excuse.
Yeah, when I read PCI controls recently, I thought, this all translates pretty well to Kubernetes. Sure, we don't have a DMZ anymore. It's now like pods with ingress, but whatever, it's roughly the same concept. I can trivially translate it to what I need to do with network policies.
And the auditors are totally fine with that. They're people who are making an independent assessment, and we found that we had a pretty good experience with ours. But the important thing is to actually take responsibility for the security, use the audit as just a means to an end, an excuse to do all these things, but actually think seriously about your customers and what it would mean for them if their data gets stolen, and thinking creatively, like red teaming a little bit in your head. How would I actually do it? And can I make it not possible to do it? And go from there.
You've got to go the Rust approach of just eliminating entire classes of problems, because they only have to be right once.
Yeah. And if you can, that's great. Definitely.
So what's next for you now? So I know you're in the UK at the moment. You work in a Berlin-based company. You don't just do software engineering nowadays.
No, I do a little bit of, enterprise sales and business things and all that kind of stuff. And in my spare time, I do a bit of kite surfing and generally enjoying living in London. And yeah, all is well. But what's next for me? Hopefully more of the same. I think Restate has been a lot of fun the last year and a bit. Hope to be there much longer than that.
So one last question. How can people get in touch with you?
On Twitter, my name, Jack Kleeman, Kleeman. I'm extremely addicted to Twitter, so you can find me there.
It took me like 3 years to find out that when I get sent a link to Twitter, I can scroll up in the thread to see the context. And I didn't get it, because I'm not addicted to Twitter.
Context is important at all.
Just keep scrolling down.
Yeah. More information. Fair enough.
All right.
Awesome.
Thank you, Jack.
Thanks very much. Next time.
Till next time.